Hi all, today we are going to explore one of the most important topics in physics, that is classical mechanics. So everything from constructing bridges to launching satellites depends on understanding how forces affect motion, right? So throughout this presentation, we'll examine what forces are, how vectors work, how different forces combine, and how friction influences movement. By the end, you will understand the fundamental principles en- engineers use every day to solve real world problems. Okay, so let's get started. So, before studying formulas, let's observe the real world. Consider this offshore oil platform. Okay, it experiences several forces simultaneously. What are the forces it experiences? It experiences gravity pulls, right? It pulls the structure downwards, right? Gravity pulls the structure downwards. And what about the wind? It pushes it sideways, right? The wind will pushes it sideways. And what about ocean? Ocean current exert horizontal pressure, right? The ocean current exerted horizontal pressure. And structural support providing balancing reactions, right? So engineers cannot study these forces separately because they combine to produce one overall force known as the resultant force. So all these forces together called as the resultant force. So designing safe structures required calculating this resultant accurately so that the structure remains stable even during extreme weather. Okay, so that is why it is too important. Now let's examine the anatomy of a force. So what is a force? Basically, force is completely described by two properties. What are the two properties? That are magnitude and direction. Okay. So magnitude tells us, what does magnitude gives? It tells us how strong the force is and how is it is measured in Newton. So magnitude will give you the strong, right? The strength. Okay, clear? And what about direction? Direction tells us where the force act. Okay, where the force is applied. Clear? So it is classified as a vector quantity. So it is a vector quantity. Okay. So when we draw forces, we represent them using the arrows. Okay. While the arrowhead shows the direction. So the graphical representation helps us engineers analyze multiple forces efficiently. Okay, so you can see how the forces are shown here, right? Now let's see scalar versus vectors. So physical quantities fall into two categories. Scalars that have only magnitude. For example, you can take the cases of mass, time, temperature, energy, and distance. And what about vectors? It has both magnitude and direction, right? It has both magnitude and direction. For example, you can take the case of force, velocity, acceleration, momentum, and displacement. So this distinction is extremely important. For example, traveling 20 kilometer is simply a distance, right? But traveling 20 kilometer north represent displacement because direction is included. Okay. So traveling 20 kilometer, you can travel at any direction. Okay. But traveling 20 kilometer to north, it represent the vector quantity. Okay. Clear? So these are the examples. Okay. So here you can see the diagram, right? So this diagram illustrates equilibrium. So the object weight act downward due to gravity. Okay. So the object weight act downward due to gravity. Clear? While the supporting surface produces an equal upward reaction force. So that is the reaction force. Okay. So since these forces are equal in magnitude and opposite in direction, the resultant force is 0. So the resultant force, what is the resultant force here? It is equal to 0. Okay. So according to Newton's first law, when the net force equal to 0, an object remains at a rest or continues moving at a constant velocity. So buildings, bridges, furniture and stationary vehicles all rely on this principle. Okay, so here R is equal to W. So when opposite forces are perfectly matched, they are balanced and the resultant is 0, right? The net force will be 0, which means object remains stationary with no acceleration. Okay. So what is the algorithm of linear addition? So when two or more forces act along the same straight line, vector addition becomes straightforward. Okay. So if it is in the same direction, you can easily add them. Okay. But what if the forces act in the opposite direction? You will have to take the negative. Right. So if the forces act in the same direction, we simply add their magnitude. For example, 1 Newton plus 2 Newton equal to 3 Newton, right? However, when forces act in opposite direction, we subtract the smallest force from the larger one. So in this case, 3 is the larger force and 1 is the smaller force. So we will minus 1 from 3, which will give you 2. So we subtract the smaller force from the larger one and the resultant act in the direction of the larger force and the resultant will act in the larger force. That is how actually it happens in real life, right? So when you push someone too hard, they will fall to the direction that you push them. And even if they resist, the force of the person which is higher, the other one will fall, right? Just like that. So this method is widely used in mechanics, transportation and engineering designs. Okay, now let's see how we'll be using the parallelogram law. So when forces act at different angles, ordinary addition no longer works. Instead, we use the parallelogram law. Okay, so for that what you have to do? First, you have to draw both vectors from the same straight point. Okay, see? So this is our force. Now you have to draw the vectors. Okay. Next, complete the parallelogram by drawing lines parallel to each vector. So this was our first one. This is our second one. Okay. So you will be connecting the dots just like this. Okay. Finally, draw the diagonal from the common origin. So from the common origin. Okay. Clear? So this diagonal represents the resultant force in both magnitude and direction. So this graphical technique provides an accurate solution whenever two non-parallel forces act simultaneously. Okay, so first take the force, secondly draw the line, right? Then you have to draw both the vectors from the same starting point, right? After that you can extend that both. And from the meeting point, you have to draw this one. This is how we do that. Okay. So now let's see how to do it in practically. Okay. So let's apply the parallelogram law to an example. Here, one force act horizontally while another one act at an angle. Okay. So using the chosen scale, we can draw both vectors. So you can complete the parallelogram. Okay, and measure the diagonal. So the diagonal gives the resultant vector. So you have to notice that the resultant lies between the original vectors because it represents the combined effect of both vectors. So engineers frequently use this method in crane operations, constructions and mechanical systems. Okay, so you can see here the forces given as 4 Newton, force 2 is given as 5 Newton, the angle is 45 degree. So what is the resultant? That is 8.3 Newton at a 20 degree from the 5 Newton force. Okay, see, this is how it will work. Okay, so due to an angular divergence, the resultant is 8.3 Newton, not simply 9 Newton. So direction indicate the final value. Okay. So vectors appears everywhere in engineering. In lifting operations, crane experience vertical lifting forces along with the horizontal forces, which is caused by movement and wing. Similarly, aircraft experience the thrust, right? So lift, drag, and weight simultaneously. So engineers calculate the resultant of these forces to predict movement, ensure stability, and improve efficiency. So without vector analysis, safe engineering design would not be possible. Okay. So you can see the linear vertical example here and the angular or horizontal example here. So in linear or vertical example, carry heavy loads, require balancing upward lift against absolute downward weight. Okay. So F1 plus F2 should be equal to balanced. And in angular or horizontal example, if the resultant vector of the tugboats, we are taking the case of a tugboat here, exceeds the water resistance, the ship moves along the resultant path. Okay. So you can choose any example of your choice. So now let's take a look into friction. So friction is a force, right, that opposes the motion whenever two surfaces are in contact. While friction reduces efficiency by converting useful energy into heat, it is also essential for daily life. For walking, driving, writing, and gripping objects, all depends on friction. High friction surfaces provides great grip, right? Whereas low friction surface allows smoother movement. So engineers select material carefully depending on whether they want to increase or reduce the friction. Okay, clear? So you can see the examples here. Okay, now let's see the friction activation curve. So here you can see the graph, right? So the graph explains how friction changes as applied forces increases. So initially you can see the static friction, right? We are starting with the static friction. It increases to match the applied force. Okay, preventing the movement. Once the applied force reaches the maximum static friction, what will happen? The object begins moving. After motion starts, friction decreases slightly, right? And become dynamic or kinetic friction. So dynamic friction remains relatively constant while the object continues moving. So this explains why pushing a heavy object is hardest thing at the beginning. Later on it is much smoother, right? So what is static friction here? It matches applied force exactly. There won't be any motion. Then what is the limiting friction? The absolute maximum static threshold before slipping occurs. And what is dynamic friction? Once moving, friction drops. It requires less force to keep an object moving than to start. So that is, for example, you can mention anything like moving an object at the beginning, it will be difficult, but once it start moving, it will be very easy than compared to the initial friction, right? And when machine parts move against each other, friction converts useful mechanical energy into heat. So this energy transformation reduces efficiency and causes wear. So engineers minimize those losses using lubrication, bearings, smoother surface, and improved materials. So reducing friction not only saves energy but also increases the lifespan and reliability of machines. So here you can see everything together. Okay, so motion depends on the balance between the total applied force and the opposing friction, right? So if the applied forces are smaller than friction, the object remains stationary. But if the applied forces exceed friction, a resultant force exists, causing acceleration according to Newton's second law. So understanding this relationship allows engineers to predict and control motion carefully or and accurately. Okay. So, to conclude, we have learned that forces are vectors characterized by magnitude and direction. We compared the scalar and vectors, studied equilibrium, and learned how to add vectors, right? Both linearly using parallelogram law and explored friction and energy laws. So, these concepts form the foundations of engineering mechanics and are applied in civil engineering, aerospace, mechanical design, transportation, and countless other fields. I hope it is clear for you. Thanks for watching.